Okay, so in my other video, I explained to you what you were going to be doing. So now these are your actual notes, starting off, with the first activity. So please note, notes are updated based off of activities. So as we progress through the activities, your notes will also progress. So again, the first lesson is 1.1, investigating the scene, and this covers activities 1.1.1 through 1.1.7. So the first activity again is 1.1.1, which is called a sketchy scene. So the case brief, I already showed you the video on that. So if you just click on that video, or in this case, I'll do it. All right. All right. So moving on, I'll show the video for that in one moment. Moving on. So who's Anna Garcia? So this is a picture of Anna Garcia. She's 20 years old. She's 5 foot 6 inches, weighs 135 pounds, and her occupation is she's an undergraduate college student who works part-time in a research lab in this Gentry Life Science building. So documenting the scene, some search methods. So when people are doing crime scene investigations, you have to be very strategic so that you don't spend a lot of time, but you also don't miss valuable information. So the methods that you can use, the first one is called a link method. This method is not a geometric pattern or easily definable, so there is no set pattern. Method seeking to find association between evidence. Investigators evaluate the scene and then proceed through the area in a systematic and logical fashion, based on the notion that one type of evidence leads to another. Works with large and small indoor and outdoor crime scenes. So it's like you're trying to link pieces together based off of the evidence that you find. The second method is called the line or strip method, used on large outdoor crime scenes. Members of the search team arrange at irregular intervals, usually arm length, and then proceed to search along straight lines. So, like you would start here and then you would work your way down this line, like different members of the team. The grid method is used on a large outdoor crime scene. Researchers follow the first line pattern and search the same manner as the line method. Once the first line pattern is complete, searchers realign on the other pattern. So if you're at this point, you're going to start here and then you're going to work your way down. Then you're going to go back to the origin and you're going to work your way across. And that is what they will be doing for the grid method. And again, that's on a large outdoor space like a field if you were trying to find a body or something of that nature. Then you have something called the zone method. So that's used on crime scenes that are comprised of readily definable zones, such as in houses or buildings. Teams are assigned small zones for searching, then other appropriate searching methods are employed in each zone. So what that means is, say you have like a team of um, about 20 people, right? You have 4 different zones. So 5 people are going to be in zone 1, 5 people are going to be in zone 2, 5 people are going to be in zone 3, and so forth. And then you would use one of these other search methods like the grid method or the line method or the spiral method or something like that, and you would do that within that zone that you're housing, and it's usually inside of a house or some type of apartment or something like that, so that way everybody's not looking in the same zone. Then you have something called the spiral method or the inward or outward. This is usually somewhere where there's no physical barriers, like outside in the open water. So if you remember over the summer, like when they were trying to find Naya Rivera, like they would have used a method like this because there was no barriers out there. She was just like, her body was in the lake or things of that nature. So you can either begin at the critical point of the crime scene, which is the outward spiral, or the outer edge of the crime scene, which is the inward spiral. So either you're going to start in or you're going to start out and work your way in. So you can either work where that person was last seen, and then just kind of work your way out. Having probably some divers in there looking in the water, things of that nature. You might have some airplanes flying to see if they can spot anything. So things of that nature. Like there's not a lot of barriers there. It's just open water, open space. Then you have the wheel or the ray method. That's used on small circular crime scenes. Investigators start from a critical point and travel outward along many straight lines from this point. So you start in the center and you just kind of work your way out, like in a wheel or ray method, and that's what it's called. So going back to our presentation, some career connections that are made is forensic sciences, and those are sciences that use the application of scientific knowledge to resolve questions of civil and criminal law. Um, so think about the people that they have testify, the forensic scientists, medical examiners, things of that nature. Um, People that do the lie detector test, all of those things. Like those are people that apply scientific knowledge, but they help to solve civil and criminal information. And then the main thing that we talk about is biomedical sciences, and those touch on different areas. So the biomedical sciences are involved in many facets of our day-to-day lives, including but not limited to research, medicine, healthcare, pharmacology, and medical tech, and even forensics. Biomedical sciences have training in life science with a focus on medicine. So that's like the broad general thing is to be a biomedical scientist, and then from there you can specialize in different stuff. I know this might be a little hard to see, but this is called character traits of biomedical scientists, things that you will need. So you have to be a good communicator. That means practice all forms of communication, listening, speaking, and writing in order to share info with others in a clear and organized way. You have to be collaborative. That means that you have to interact with people to accomplish a common goal, sharing ideas, resolving conflicts, sharing work responsibilities. You have to be a problem solver, works through the details of the problem to reach the best solution. You also have to be ethical, so you have to consider ideas of honesty, fairness, accountability, and concerns about others and their environment. You have to be creative, so you got to use your imagination to develop original and innovative ideas. You have to be a critical thinker. You have to observe, analyze, and interpret, reflect, and make evaluations and draw logical and well thought out conclusions. You have to be accountable, so you have to take responsibility for decisions, actions, and behaviors. You have to be persistent, so continues to follow a course of action in spite of difficulty or opposition, because most of the time these people that work in this field, they don't just solve the case instantly. If you look at some of these shows or some of these movies, it takes years, decades even, but you have to be persistent. You have to be honest. So you have to operate with sincerity and truthfulness in your research and in your communication with others. So those are some key characteristic traits of a biomedical scientist, but also some traits, everyday lives. And that is our notes so far for based off of activity 1.1.1. Again, I will be adding to the notes as we continue to progress through the activities. Have a great day.